Welcome back to Mrs. Bisson's virtual classroom. Today we are going to be learning how to identify types of angles and solve angle problems. You will need a sharpened pencil with an eraser, a calculator, your guided note sheet, and you'll follow along and fill in the spaces as you are prompted in the video, and of course your headphones. If you are missing any of these items, please pause the video, retrieve the items, and resume the video when you get back. So let's review. I know that in the 4th grade you worked with angles a little bit and using protractors and things like that. So what is an angle? Well, an angle is a shape formed by two lines or rays diverging from a common point, which is called the vertex. So let's look at our diagram here. We have here, this is the vertex, and then we have each individual arm or ray diverging from the vertex. So it's just an angle. And here with the arrow, that's actually the measurement of the degrees of the angle. So let's look at how do I measure an angle quickly. I'm not going to go into too much detail with this, but you can practice with protractors, just kind of refreshing your memory about how to use these. So how do I measure an angle? Well, you place the protractor on the angle with the origin or the hole, and you can see there's a little hole here, on the vertex and the baseline of one of the rays. So the baseline on one of the rays here, so this is the baseline, the point that says 0 degrees. And so you'll place that on one of the rays, which I placed it here, and you can see, you can read it, and you can tell that it is 146 degrees. Now you do have to be careful with protractors because you'll see there are actually two lines that give indications of degrees. So we're going to learn a little bit more about how to identify different angles, and that will help you decide which line to use, because you'll know which type of angle is smaller than 90 degrees, which type of angle is larger than 90 degrees, so you'll know which one to use. So the different types of angles. How do you identify an angle? Well, the angle symbol followed by 3 points that define the angle, with the middle letter being the vertex and the other 2 on the legs. Okay, so we have an angle here that we're working with, and this is the example that I gave in the previous slide. So there are actually 3 different types of ways that you can identify an angle, but all ways require you to make this little angle sign. So it just looks like that. It actually looks like an angle. And you know that if you're identifying point A, point O, and point B, that you have to use all of those letters. If you're deciding to use one ray, you have to use the other ray. Okay, so, but you know from this example that the vertex point has to be in the middle. So you could say angle A, OB, or angle BOA. You will notice that in both of those examples, angle O, which is, or the point O, excuse me, which is the vertex, is in the middle. That's the rule. If you're using all 3 points, you have to have the vertex in the middle. Okay, and sometimes, if you'd like to, you can go ahead and just give the example, you can name it by just using the vertex, which is point O. So angle O. You would never say angle A or angle B unless those were, of course, the indication of the label of the vertex. So, and you notice here I've used AOB, but those will vary given, you know, the specific examples that you're given. You're going to have different name letters that indicate the points on the angle. So don't get scared if you get one that says ABC or XYZ or something like that. You know the vertex is the point there, point O, so that goes in the middle. So there are 3 different types of ways that we can label our angles. Okay, so an acute angle is an angle that is less than 90 degrees. And a good way to remember this is that they're cute. So here's a little funny picture that may help you remember that. She says, "Oh, stop it, you," and she's really cute. She's got the rosy pink cheeks, and that's an acute angle. You can see that the angle is less than 90 degrees. Here you have an obtuse angle. So an obtuse angle is an angle that is more than 90 degrees and less than 180. So you'll see this is 130 degrees. It's more than 90 and less than 180. And we're going to be using, we're going to be practicing this as well. So right angle is an angle that measures 90 degrees. It's indicated, and you see here that there's a little square shape at the vertex. And that's how you can tell, even if it doesn't say 90 degrees, you can tell even without that, that the angle is a 90-degree angle. And you'll see it kind of looks like maybe like a floor and a wall. It's a perfect 90-degree angle, right? And then finally, you may not think of a straight line as being an angle at all, but in fact it really is. So here we have a straight angle, and it's basically a line. It looks like a line. It's 180 degrees. The vertex is right in the middle, and then you have your 180-degree angle. So that's called a straight angle, and that one's really easy to remember because it's a straight line. So, quick quiz. Pause the video. See if you can identify if these are acute, obtuse, right, or straight angles. Okay, so we have our first angle, and we can tell that that is less than 180 degrees, but it is definitely more than 90 degrees. So that one, I'm going to go ahead and say that that angle is most definitely an obtuse angle. Here we have what looks to me like a straight line. So I would most certainly say that that was a straight angle. Here we have an angle that looks definitely like it's less than 90 degrees as far as what the angle is. So it's really a acute angle, so it is a acute angle, right? And finally, we have this one, and we know by looking here, we've got that square there, and what did we say before? We said that that is a right angle, which is 90 degrees exactly. So I hope that you got all of those correct. If not, let me know and we'll go through it again. Okay, so this is a funny little joke. Why is the obtuse triangle always upset? Because it's never right. And then there's the obtuse triangle, and it's an obtuse triangle because look here, there's an obtuse angle there. Okay, so part 2 is angle relationships. So an adjacent angle is adjacent angles are two angles that are side by side and share a common ray. You can see here that there are two angles there, but they share this ray and they're right next to each other. They're side by side, and they actually share the vertex too. See, vertex O. So angle relationships, types of adjacent angles. You have complementary angles, and those are angles that add up to 90 degrees. And see, you've got this lovely little square here that indicates that that's a 90-degree angle. But added together, there are actually two angles here. Those add up to 90. The supplementary angles add up to 180, and I'm going to change that real quick here because it is not 90. It's 180, and you'll see that this adds up to a straight line. You can just go like this and it's a straight line. And here's a funny little joke to help you remember what a complementary angle is. Now, complementary is not spelled the same as a complement, but that's okay. It sounds the same and it helps us. So the complementary angle says, wow, you look so cute today, because there are two acute angles making a 90-degree angle. And you can see here that it's an acute angle. So that's a cute little joke to help you remember. So angle relationships. Vertical angles are the angles that directly oppose each other. And you know what's interesting, and I know our thinking cat here is identifying this. He's identified that the vertical angles are equal. So we can really solve problems knowing that this angle is the same measurement as this angle. And you can tell that those are vertical. And in fact, this angle is the same as this angle as well. So that's something to remember. If someone asks you, what is a vertical angle? And you can say they're equal. So how do I solve an angle relationship problem? Well, step one is, of course, identifying the angle relationship. So let's look and see the information that we know here. We know that we have a straight line and we have two adjacent angles. And so the fact that we know that we have a straight line, we know that this is a supplementary angle and that it equals 180. So that's the first thing. We know that these angles added together are going to equal 180. So I'm going to go ahead and write that down. So if I'm looking at that, I know these angles add up to 180. So 50 plus 2x, or 2x plus 50, equals 180. So 2x plus 50 equals 180. Now all you're doing is solving a two-step equation, and we've already done that. So let's go ahead and make our chart that we're used to making. And we know that the operations that we're working with are addition. And the inverse of addition is, of course, subtraction, and multiplication. So go ahead and solve that and let me know, or actually check your answer when you come back. I'm not going to go through each individual step because I know that you can do this, but you should have your check on your paper, and you should also have all the steps listed. So you should have had x is equal to 65. Now we're not finished yet because you know what x is, but if you notice here it's 2x. So what you have to do is take 2 times 65, and then of course you'll get 130. So you know that this, and if we said, for example, this is C, A, B, and I'm putting just points on here to help you, and this is D. The question might ask you what the measurement of angle, let me put D there, DCB. So then you would say, because you know that this is 130 degrees, you would say that the measurement of angle DCB is equal to 130 degrees. Okay, and you all obviously want to make sure that you do your check on here and go through all the steps and show your work. If you did not get that, please raise your hand and I will come and help you. So this is the familiar cat again, who we've been seeing quite often lately because we've been building on each skill with each lesson that we've learned before. So this looks really familiar, and it does, because these are just equations. You've done this before, you know how to do this. You're just learning some new terminology about angles, and I'm confident that everyone will succeed in these concepts that we're learning today. So here's another angle relationship problem. Now this one's fun because when I'm identifying the angle relationships, I can see actually that these are in fact vertical angles, and one of the primary elements in a vertical angle is that they are equal. So I could look at this and say these are vertical angles, they are equal, and say that this is actually, because this is 43 degrees, I know that this angle is 43 degrees. However, there is also a way that you can do this, and you will get in depth into this when you start doing 3-step equations and 4-step equations. But here you could actually write it, if you wanted to, as 3x is equal to 43. Now, if you'd like to go ahead and solve that now, you'll notice that when you solve for x and multiply by 3, because it's 3x, you will get 43 degrees. Please let me know if that does not make sense, and we will be going over some additional examples. But in vertical angles are equal. So you can actually look at that and see that those are equal. And therefore, that angle is 43, and 3x is equal to 43. Okay, here's another one. So what do you know from looking at this example? Well, you can see that, and I actually should put a little square here. So now look at it. What do you see there that tells us what the angle relationship is here? Well, these angles add up to 90 degrees, to a right angle, right? So we know that it equals 90 degrees. So I'm going to say 3x plus 45. It could be 45 plus 3x, that's okay. I just find that when I put the variable in the front, it's a little easier for me to solve. So I like to do that. Okay, so go ahead. I will help you with the chart as well. You know we're doing our chart that we like to do. And we know that we're working with addition. And the inverse operation of addition is subtraction. And we're dealing with multiplication. And the inverse of multiplication is division. So go ahead and solve that one. Oh, and I do want to mention that we know that these add up to 90 degrees. Therefore, they are complementary angles. So complementary angles add up to 90 degrees or a right angle. Supplementary angles add up to 180 degrees. Okay, and we are going to review that some more as well. So here you should have gotten the answer of 45 degrees. Okay, so if you did not get that, please let me know. Please make sure that you're using your checks when you're doing these example problems as well. I'd like to see those on your paper. Okay, so we went through a lot today, but we're going to also do a lot of practice as well. I know that you guys can do this. These are all just building on skills that you already have. So I'm excited about getting to practice, so let's get to work.